Continuing our discussion about ossification, we're going to move into the endochondral ossification. Now, endochondral ossification, just like the intramembranous ossification we covered previously, they both start in utero. So we're looking about 6 to 8 weeks after conception at this point. Now again, it's a range because it changes and varies person to person. But the difference here is, while they both start very early on, endochondral ossification, like the name implies, endo in chondro cartilage, endochondral ossification starts with a cartilage model. This is starting specifically with hyaline cartilage. While that intramembranous ossification we already discussed was the actual membrane starting material. So we're starting with hyaline cartilage as the model here. Now notice that if you look at this initial model, it doesn't look like any particular long bone. The idea is the hyaline cartilage model is just a starting point. As the actual bone is growing and forming into what we think it should look like, the cartilage is growing, the bone is being replaced inside of it. It will develop into it eventually, but initially it's not there. So we start with this hyaline cartilage. The hyaline cartilage, don't forget, came from mesenchymal cells. Those mesenchymal cells made the chondroblasts, chondrocytes. Chondrocytes basically created the hyaline cartilage. So this hyaline cartilage, this initial model we have here, we're starting with hyaline cartilage, and at this point, we're going to have this kind of layer around the outside of it. This layer around the outside is referred to as the perichondrium. The perichondrium is just formed around the outside once the chondrocytes are there and present. So basically, once it's hyaline cartilage. But now, that's when the actual formation of bone can start. It starts off very slowly, very subtly. What happens is, you'll have areas inside the cartilage that start to become calcified. These calcified areas inside the cartilage start to cause the chondrocytes to die off. Because remember, the actual hyaline cartilage, like all cartilages, is avascular. So all the nutrients must diffuse into the cartilage. If you're calcifying the matrix around a chondrocyte, it can't get its nutrients. So these chondrocytes are starting to die off. As the chondrocytes die off in this area here, then what's going to happen is they're simply disintegrating. They're breaking down, creating open space. That open space eventually allows for what will become a medullary cavity, but it's not yet. That open space allows this blood vessel to come in and then start to spread around. So it's the bringing of the blood vessel in that helps to create the space and allow it to have osteogenic cells. It's bringing in all that it needs to start forming bone. So you're bringing in these osteogenic stem cells that will become the osteoblast cells that can grow and make the spongy bone. But while that's occurring in the middle of this hyaline cartilage, you've also then having cartilage growing on the outside ends. This whole model is getting bigger and bigger still. So as that developing fetus is growing in size, the cartilage is growing as well. We're forming the spongy bone in the middle, cartilage is growing the outside edges. Now, as this keeps on growing, you'll have more and more and more spongy bone growing. Eventually, the outside around the spongy bone can have this periosteum forming the outside edges. The periosteum is basically allowing for a creation of some bone and some structure on the outside of the model as well. So we've now changed into this periosteum to make this what's called the periosteal collar. And these osteoblasts create it all the way around the outside of the actual forming bone. By creating this periosteal collar on the outside, it allows the inside spongy bone to keep growing and growing more. More blood vessels, and therefore all this remaining cartilage, you see there, what was between the periosteum and the forming in the middle, now becomes bone. So it's all this compact bone on the outside edges. So we've basically created this, what would be the medullary cavity, from spongy bone to eventually making a bony collar, which will be compact bone on the outside edges. Now, all this process is going through weeks and months of formation. It's not happening in simply 1 week or a day. So it's taking a long period to go through this. So as we're looking at this structure, let's just blow this up to full screen and go through it one more time. We start off with the hyaline cartilage here. That hyaline cartilage is the initial formation, the initial mold that you'll start with. From there, some of the cells start to have calcification occur around them. This calcification of the matrix is going to cause the chondrocytes that are present to start to die off. As those chondrocytes die off, the cartilage matrix that was around them is also dying off. That's creating this space in the middle of the bone. This space in the middle of the bone, then now without cartilage, allows the blood vessel to come in. As that blood vessel comes in, it brings more calcium, more osteogenic cells, and you create more spongy bone. While this is also occurring, the periosteum is being formed on the outside of this cartilage model. The periosteum will continue to grow from osteoblast cells, and eventually that will form a compact bone collar around the outside. That compact bone collar, in conjunction with the blood vessels inside, create a nice, solid, compact bone on the outside around where the shaft would be, and the inside then is going to have these capillaries moving up. All these capillaries are heading up into the actual cartilage. As those capillaries move into the cartilage, with the periosteal collar around the outside, that allows that cartilage to end up being killed off, so it dies off, and more spongy bone can grow there. So that's kind of where we're at so far in the process. All of it is because that periosteal collar is moving up along the shaft of the bone, and the capillaries inside are heading up towards the ends of the bone. But while all that's occurring, this cartilage out here is still growing. It's not calcified. So you still have cartilage on both ends of the bone, or in this case, they're showing just one end of the bone, because that cartilage must be present to allow the bone to continue to grow. All right, now let's shift to what happens after birth, because those ends remain cartilage throughout birth. After birth, we're going to start with these secondary ossification centers. The secondary ossification center is in the cartilage that's at the end of the long bones. This was the primary ossification center. So primary is where we were. We started in the primary ossification center. We've grown to the secondary ossification center. These secondary ossification centers will go through the same exact process as the primary. You have the calcifying of the matrix, the chondrocytes are dying off. That means the cartilage matrix is disintegrating, capillary comes in, blood supply means more osteoblast cells, forming a spongy bone, and you're creating actual calcified matrix of the osseous tissue. But we must leave some cartilage there. No matter what, you leave some cartilage right here, and then some cartilage along the outside edges. Those two cartilages are important to allow the bone to keep growing throughout childhood and adolescence. Keep increasing the length of that long bone. The way it works, this epiphyseal plate, that cartilage keeps growing all throughout childhood into adolescence. As the cartilage keeps growing, that bone gets longer and longer. We'll talk about that a little more later. The same time as that keeps growing, you can't just make the bones longer. You gotta make sure that the ends of the bones are proportional. That's where this articular cartilage comes into play. The articular cartilage is covering the end of the long bone. Now, it serves more than one purpose. One purpose being cushioning, provides cushion on bone. But the other purpose here is it allows for that end of the bone to grow proportionally. So both the articular cartilage as well as the epiphyseal plate, both those hyaline cartilage keep growing throughout childhood, helping that bone increase in length and grow appropriately. So this idea of the actual endochondral ossification, let's go through the whole thing one more time. So we're going to go back and blow this up full screen and go through the whole process. Now we're looking at, start with the hyaline cartilage model. That hyaline cartilage model is going to be based off of the chondrocytes. But those chondrocytes is going to have a problem initially occurring because those chondrocytes end up having a calcified matrix around them. That calcifying of the matrix is going to cause those chondrocytes to not be able to get nutrients, and that means the chondrocytes die off. As those chondrocytes die off, the cartilage matrix around it is also dying off. Now, in this model, we also have this perichondrium around the outside of the cartilage. It's the initial steps of what will become a membrane around the bone, but right now it's perichondrium. So we keep having the calcification occurring in the cartilage. Eventually, a large enough space is created where a blood vessel can come in. That blood vessel is going to come into the bone, that's creating a bone basically, bringing in nutrients and bringing in the osteogenic cells. Those osteogenic cells, those osteoblast cells, start to create spongy bone. At this point, you also have the periosteum forming. The periosteum is going to be around the outside edge of this bone. But notice the periosteum is only around the shaft, the middle. It's creating the periosteal collar. So it's creating this layer of compact bone around the cartilage model. So now between the calcification of the cartilage matrix and this periosteal collar, which prevents nutrients from diffusing in for the cartilage continues to die off. The chondrocytes are dying off, disintegrating. The actual matrix of the cartilage is then dying off, allowing all of the bone to be created along the actual shaft of this bone. Now, at this point, you have all these blood vessels inside of the actual growing bone. Those blood vessels are moving up into the cartilage. As those blood vessels move up into the cartilage, it's allowing the cartilage to become calcified again, dying off, and more osteoblast cells are coming in to form. But no matter what, the end up here, or the ends on both ends, will remain cartilage. That cartilage keeps on growing. That bone keeps on growing because of the cartilage. Now, at this point, this primary ossification center, these are the primary ossification centers, the center of the bone. That primary ossification center is going to keep growing in length and size until birth. Now, at birth, you'll have that forming bone, which at this point, this is a pretty decent chunk of bone, but it's not finished. Because for birth to occur and actually come out of vaginal birth, the bones must kind of be able to be a little flexible and be able to move. So think about the shoulders and the hips, the knees, the elbows. They don't really have the stability yet. That's because those ends of the bones are still cartilage. But after birth, you'll start with the secondary ossification center. Same exact process. This secondary ossification center starts with the calcification of the matrix. As the matrix calcifies, then you have more osteoblast cells coming in on these blood vessels. So as more blood vessels come in, you continue the growth of the spongy bone. Spongy bone keeps growing until there's only a little bit of cartilage left. You're going to have the epiphyseal plate left, as well as having the articular cartilage left. Both the articular cartilage and epiphyseal plate will remain throughout childhood into adolescence, because that's how the cartilage keeps growing, and that's how the bone keeps elongating. So pretty much, that is the process of endochondral ossification. we're looking at the growth of bones, of long bones. Cartilage to start with, breaks down and is destroyed. Bone osseous tissues come in. We then have the osteoblast forming spongy bone, forming compact bone by the periosteum, and we increase in length, but the cartilage remains until that bone is done growing in length. Once adulthood and adult height is reached, then that cartilage of the epiphyseal plate becomes the epiphyseal line. Epiphyseal line means no more cartilage. That bone cannot increase in length. But the articular cartilage stays there throughout life because you have cushioning of bone on bone. It's just that epiphyseal plate, that cartilage goes away to the epiphyseal line. So growth and the formation of the actual long bone, endochondral ossification.